In this video, we're going to look at some equations that you can use when solving problems with converging and diverging lenses. So we have two equations. First one here. So the DI is the distance of the image from the lens. The DO is the distance of the object from the lens. You'll be given that. And F is the focal length or focal point. You'll also be given that. And then once you've used that equation, you can go ahead and use the second one where we have the HI, which is the height of your image, the HO, which is the height of the object, and that will be given. And then you should be able to, you should have already solved for DI from the original equation. Notice there is a minus in it, so we might have a couple of negative signs coming together when we go ahead and use this equation. So let's take a look here. We've got a 2 centimeter tall object. It's placed 10 centimeters away from the converging lens, which is that one. And it's got a focal length of 4 centimeters. So from here to here is 4 centimeters, which means from here to here is 4 centimeters, which means our object is going to be beyond that. So we can kind of ballpark it for right there. And that's about 2 centimeters tall. So let's go ahead and let's calculate our high and our die, and then we'll come back here and we'll see if we are correct. So we'll start by calculating our distance of our image. So we've got the focal length, which is 4, and we have our distance of our object, which is 1/10. So some quick math here. We've got 1/4, which reduces down to 0.25, and we have 1 divided by 10, which reduces down to 0.1, and you subtract those values, you get 0.15. Now we want to solve for DI, so what we want to do, and this mathematically, what I'm saying isn't correct, but mathematically it is. We're kind of moving this 1 over to this side. So the distance of our image is equal to 1 over our answer. So if you take your calculator and go 1 divided by 0.15, you get 6.67 centimeters. So that's how far away our image is away from the lens. So now that we have that DI, we can go ahead and calculate our the height of our image. So we'll plug in our HO, which is 2 centimeters, given up here. The distance of our image, we calculated at 6.67. So now we're going to make it negative 6.67 right there. That negative sign gets carried along, and then our distance of our object was 10. So if you divide those out, you should get a height of minus 1.33. So that means it points down. So when we actually go to figure out where our image is going to be located with our drawings, you'll notice that it's going to be located right here. So it definitely is pointing down. And we said it was 6.67 for the distance of our image. And we know that this value was 4 to here and was 8 to there. So 6.67 looks like it could be a reasonable answer. And definitely our answer of negative 1.33 also is fairly reasonable. Let's try a different one here. Now we've got a diverging lens. So we've got a different kind of lens, different sort of answer. There is our object. So a 6 centimeter tall object is placed 12 centimeters away from the diverging lens. We've got a focal length of 4. So on to our calculations here. Now, one thing we do have to adjust is that it's a different type of lens, so we actually have to add this negative sign in. So we're going to have a couple of negative terms being added up in this one. If we don't add that negative, then this question will get our result will be on the other side of the lens, and that will be incorrect. So we're going to plug in negative 1/4 there. We've got negative 1/12. Reducing both of those terms to decimals, you should get those answers. So 1 divided by 4 and 1 divided by 12. Put all that together, you get negative 0.333. We're going to move that 1 over to this side. So essentially we're doing 1 divided by our answer, and we get an answer of minus 3. So the distance of our image is minus 3 centimeters. Now we've got the height of our object, so there's our equation. The height of our object was 6. Now we've got two negatives going on here because the DI we just calculated was negative 3. So we have negative 3. Two negatives make a positive, so that's just like having 3. And we'll divide by 12. And we get a positive height. So our image should be an upright image. So to see where this draws out now, there's our first line. There is our second line, and this one dots back. And so we've got our image forming right here. So it's definitely upright. We had a DI of 3 centimeters, and I think that makes sense because our focal length is at 4 centimeters. So it's definitely in front and upright.